Hi, hello dear students, friends. Welcome to my small session on nucleophilic substitution reaction continuation. Particularly in this session, I would like to explain you the SN1 reaction mechanism. SN1 reaction mechanism. Previous session I have explained you SN2 reaction mechanism. We told that SN2 mechanism is bimolecular, substitution bimolecular reaction. Now in this case, whatever this SN1 we are raising, this stands for substitution unimolecular nucleophilic unimolecular reaction, substitution nucleophilic unimolecular reaction, unimolecular reaction. So I think you have got a clarity of what is exactly the SN1 reaction. SN1 stands for substitution nucleophilic unimolecular reaction. We are very clear about this one. In this, the reaction takes only one step, two steps. SN2 takes one step, SN2 takes two steps. It is a two-step mechanism. It is a two-step mechanism. That is one of the point here under discussion in the mechanism, two-step mechanism. Whereas SN2 we called it as a single-step mechanism. Okay. Let us see what is exactly the type of chemical reaction or the starting alkyl halide model we will discuss. In this, what is going to happen is that tertiary alkyl halides or any of the compound halide which is producing a stable carbocation, that is said to be undergoing SN1 reaction comfortably when compared to the SN2 reaction. At the same time, this reaction is going to take place in the presence of polar solvents like water, alcohol, etc. Okay, a strong nucleophiles. Okay, this is what one of the short information. I will give you an example. Hydrolysis. This hydrolysis of this alkyl halides is an example for nucleophilic substitution reactions, whereas alkaline hydrolysis of tertiary alkyl halides is the best example for demonstrating SN1 reaction. Okay, so I can say what is that example? Alkaline hydrolysis of tertiary alkyl halides is an example for this SN1 reaction. Not only alkyl halides, sometimes there are some special cases are there. In those special cases you will come to know some of the benzyl halides, some of the allyl halides, they also readily gives the SN1 reaction due to the formation of most stable carbocation which is required for this SN1 reaction mechanism's first step in this alkyl halides concepts. Okay, so this is an example. If anybody asks in the exam, you can give that one. The overall reaction by taking a particular tertiary alkyl halide, I will give you, that is tertiary butyl bromide I am taking. This is tertiary butyl bromide I am taking. If this tertiary butyl bromide is reacting with alkali sodium hydroxide, this tertiary butyl bromide will give tertiary butyl alcohol CH3 thrice COH with the removal of bromide from this alkyl halide. So what is CH3 thrice CBr? That is nothing but tertiary butyl bromide. Tertiary butyl bromide. We got the product, that is nothing but tertiary butyl alcohol. Tertiary butyl alcohol. This is the overall reaction which we are going to discuss when we are taking the SN1 reaction and its mechanism in the exam. We are going to understand this one step by step as per the reaction mechanism. As I have already told, this reaction mechanism takes 2 steps. So it is a 2-step mechanism. In that, I am going to tell you the step 1 now. In the case of mechanisms explanation. Okay, let us see what is exactly the step 1. Step 1 is the mechanism step where carbon halogen bond is going to break heterolytically, which produces a stable form of carbocation and separates the halide ion. That's what one of the most important point under the discussion. So we will take this carbon halogen specifically. When we have methyl groups are there, that methyl groups also we can indicate like this. And in this first step itself, the bond is going to separate out, and it is a slow step, and this step requires some energy. That slow step is going to become the rate determining step in the reaction. And RDS we can call, this is RDS, which produces actually in the first product as one of the planar carbocation. Planar carbocation. And this will be separated out, which is called as bromide ion. So this is leaving group. This is the carbocation, tertiary butyl carbocation with sp2 hybridization. This is tertiary butyl carbocation, which we are calling as stable carbocation. When it is a tertiary butyl carbocation with sp2 hybridization, it is said to be exhibiting planar geometry. So in such a case, what will happen? This stable carbocation allows the attack of nucleophile either side of the carbon. So that results, we have 2 types of configurations in the product, that may be retention of configuration or that may be inversion of configuration. So it happened only in the case of SN1 reaction mechanism, where in the case of SN2 mechanism we only got the inversion of configuration only as the nucleophile attacking the carbon of alkyl halide side opposite to the halogen in that case. So let us carefully observe the step 2. So what I am going to tell you in the step 2 is nothing but the carbocation is said to be attacked by the nucleophile to form product. Okay. So what is the carbocation? Here we have, this is the carbocation, and this carbocation is going to get attacked by a nucleophile. That nucleophile we are calling as OH minus. This can attack the carbocation in these two different directions. In one direction, this is A direction, this is B direction. Suppose A direction, we are saying that A direction is nothing but retention of configuration. B direction is inversion of configuration. What is A direction? Retention. What is B direction? That we called as inversion of configuration. So what is retention means? Like how the alkyl halide is there, in the same fashion the displacement of halogen takes place along with the help of nucleophile. Nucleophile is removing halogen of the alkyl halide and taking place on the carbon. Then we will get the same configuration that of alkyl halide alcohol. So alcohol we will get which is having same type of configuration to that of alkyl halide when a nucleophile is attacking the tertiary butyl carbocation, which is stable. So stable will give this type of configuration. The other one is if the nucleophile attacks in the opposite side, back side, rear side of the carbon, then we will getting a product. The product will be inverted configuration, inversion of configuration. So we have a possibility of getting this type of retention inversion of configurations 50-50%. That mixture of solution we can call in this SN1 mechanism as racemic mixture according to this nucleophilic reactions. I am going to tell you one thing. Whenever you have optically active alkyl halides you have taken, that optically active alkyl halides also will give such type of results in SN1 reaction mechanism. So what is SN1 reaction? SN1 reaction stands for substitution nucleophilic unimolecular reaction. Alkyne hydrolysis of tertiary alkyl halides is example for this one. The overall reaction we have considered this one as tertiary butyl bromide reacts with alkali gives tertiary butyl alcohol. For this reaction is explained by taking two-step mechanism. In the first step, it is a heterolytic fission where the carbon halogen bond is getting completely cleaved, carbocation formed with a stable configuration with a planar geometry, and that carbocation we will call it as tertiary butyl carbocation. That tertiary butyl carbocation is said to be attacked by the nucleophile OH minus either side of the carbocation, resulting two types of products, and that products are called as retention of configuration and inversion of configurations. Okay. Now it is a part of chemical kinetics related information. Anything you want to conclude with this one, then you can tell one thing. In this SN1 reaction, the rate as per the slow step RDS and is said to be directly proportional to only the single concentration of alkyl halide. That alkyl halide concentration power 1 only will come. That's why when you are talking about the order of this SN1 reaction is said to be first order reaction. In this reaction is involved by only single molecule in the rate determining step that decides the order of reaction. One molecule is changing the entire process is also called as unimolecular reaction mechanism. Okay, I hope you understand this SN1 reaction mechanism followed by the SN1, SN2 were discussed in the last session. This is what the explanation of SN1 reaction mechanism. In this session we have concluded. Thank you very much.